Okay, welcome to a video on solving trigonometric equations, which you've already done, but we're going to take a little twist on it and solve them by graphing today. We're going to use our graphing calculator as well, so have that ready. All right, we're doing the back page of the fourth page of the notes you have. Title is Solving Trigonometric Equations Algebraically versus Graphing. So here's what we're going to do. Here's our equation. It says solve equation graphically, or sorry, algebraically first. So we're going to solve this using the techniques we already know, and then we're going to solve it by graphing to see if we get the same answer by finding intersections. So here's 2 cos 2x equals 1. First of all, you can divide by 2, and you get cos 2x equals a half. So that 2 has gone over there. Now this tells us we have cosine of some angle gives us a value of a half. So thinking about our unit circle work, all right, so some angle that produces a cosine value of a half. So here I've spun it, and I've spun it all the way to here as well. The reason I've spun to this location and this location is because here the cosine, or the x value, is a half. All right, so positive a half. And the angle to get there, what is it? Let's think about that for a second. If this is a half, this is a 30, 60, 90 triangle, so this must be root 3 over 2. Likewise, in the bottom triangle, if this is a half, this is negative root 3 over 2, negative y value. But the x value is a half or positive for both. So this angle, again, if this is a root 3 over 2 here, then we know this angle must be 60 degrees. But giving it in radian measure, this one instead of 60 degrees must be pi over 3. All right? So to go here, it's pi over 3. So that 2x, that angle must be pi over 3. Also, to go all the way around and get to this part, which is also the same value of a half, that angle must be 5 pi over 3. Okay, so that should not be so bad. It's exactly the kind of work we've been doing before. Pi over 3 and 5 pi over 3 both produce the x value of a half. However, there's going to be more values. That's within 2 pi. It's within one spin, because that's what it says here, 2 pi. But what if we go beyond 2 pi? We can go beyond 2 pi and get to the same locations, right? So let's say we go once around and then to here. Once around is like 6 pi over 3. And if we do one more jump here, that's 7 pi over 3. So right now you might be thinking, why are we including this angle? It's beyond the single spin that this is saying. But later, when we take this angle and actually divide it in half, because that's what x is going to be, those angles will no longer be beyond. You'll see that in just a moment. So I did the one angle beyond here. And now what if you went once around and then around again to here? That one would be once around again is 6 pi over 3. And then you go 5 pi over 3 more, which becomes 11 pi over 3. All right, so those two angles have been expressed this way and then this way again when including a full spin. So now to solve for x, we're going to divide everything by 2. So x must be this divided by 2, which is pi over 6. This one divided by 2, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All right, so those are all the possible values of x, the angle that will create an x value of a half. And notice that all of these are within 2 pi, because this 11 pi over 6 is not quite 2 pi yet. All right, so those are 4 possible angles, so 4 possible answers to this equation. And now to do it graphically. So graphically, now if you look at this, you just learned all about graphing trig functions. So this trig function, let's look at the first one it gave us. Remember this 2 in the front is the amplitude, so that's going to tell us the cosine wave, instead of being 1 high, it's going to be 2 high now. It's going to be twice as high. The amplitude is 2. It's going to reach all the way to 2 and negative 2. And then this number here is your horizontal compression or stretch, right? And since there's a 2 there, that tells us it's going to be half as wide as it normally is, right? Half as wide. So here's the graph. Let's take a look. Here's 0. Let's see. Yeah, okay. So cosine always begins at the top and then goes down, right? But instead of beginning at 1 and going down, it begins at 2 because of the 2 in front. The amplitude is twice as high. So this is 2, and it goes all the way down, and it's cut off the bottom here, but it goes all the way down to negative 2, and then up to 2 again, and then down to negative 2. So instead of going 1, 1, 1 to 1, 1 to 1, it goes all the way to 2, negative 2, 2, negative 2, like that. And then the 2 here tells us it's half as wide. Remember that a normal cosine graph had a period of 2 pi, so if it went down and up and came back to the starting point, that would be 2 pi. But now this tells us the oh my goodness, the period is now pi. So now to go down, up, it does all that to the starting place in a distance of pi now. So it's been crushed or compressed horizontally. So there's our curve. And then here we have the curve, and here we have, where is this curve equal to a line of y equals 1? So here's a line of y equals 1. So here's the curve graphed together with the line y equals 1. And when you look at where they intersect, those should be the two answers, because that's where this curve equals this line y equals 1. Those two things are equal to each other right here, right here, right here, and right here. And all of that happens before 2 pi. So this point is pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6, and it matches exactly what we got here. All right, so you know how to graph these now, but on IB exams, you never really have to worry about graphing them by hand. It will always give you some kind of curve, or it will give you an equation. You have to understand it. So don't be so concerned if you're not feeling 100% comfortable graphing this one on your own. You can do this on your GDC. So let's take a look how you would do this on your GDC. So grab your graphing calculator. Let me get mine as well here. Let's try it out. So here it is. I'm going to begin by putting in two curves, right? So I have y. The first one is our trig one, 2 cosine, and then 2x. Close that. And then I'm graphing that together with the line y equals 1. So 1. And if I graph those together, I should be able to see a graph sort of like the one I had here. However, the window might not be right? With trig functions, it's really important you have the right window. It's also important that we're in radian mode right now. So let me check the mode. And I am in radian mode. I see it here. Make sure you're in radian mode. Now I'm going to go to the window and set the window right. See, right now it's between -10 and 10. But when we're talking about trig functions, it's kind of useful to see between -2 pi and 2 pi, right? Or in this case, it's telling us to look between 0 and 2 pi. So why don't I make the window 0 and 2 pi? Let's take a look at that. Why don't I go from an x value of 0 and go all the way to an x value of 2 pi? I can actually enter 2 pi. So let's see. 2, and then second, and pi is right here. 2 pi. So I'm going to look at the window between 0 and 2 pi. And the scale, 1. Okay, so on the trig function, you know, it kind of goes up and down, but that useful scale is, a good scale would be maybe pi over 2, because that pi over 2 is like the top of the unit circle, and then another pi over 2 is at 180 and so on. So pi over 2 is a good jump to do. So let's try that. Second pi divided by 2. So that's going to be the scale. It's going to jump by pi over 2. And then y, well, this one, our function has an amplitude of 2, so it's going to go all the way up to 2 and -2. So I'm going to go amplitude of 2 in the positive and then 2 in the negative direction. There's our amplitude, and the y scale is fine. So I'm going to graph that now and see what happens. Window range, all right, let's take a look. Somewhere in the window I made an error. Let's take a look again. Window, what error did I make? 0 to that, x scale. Oh, yeah, of course, that's silly. So my minimum y value made positive, it should be negative, right? -2, maximum y value should be the positive one. Let's try graphing that again. All right, there's my 2 cosine 2x, all right? So it's a pretty skinny cosine curve because it's been compressed to half its length. Remember that each of these represents pi over 2. Let's see what happens. So if this is pi over 2, then this one is pi, and it's done its full cycle in pi. So it looks pretty much like the one I had from Desmos. That's good. Now how do we find the actual solutions? Because again, this is 2 pi, so I need all the solutions between 0 and 2 pi. So each of those intersections represents a solution, and there's 4 solutions there. So I'm going to go second, and above trace is calc. Calculate. I'm going to calculate number 5, the intersection, 5. It's asking me what is the first curve. I'm just going to put enter. It's asking me what is the second curve. Well, it's already flashing on the line. That is my second curve. Enter. And the intersection. So you're going to have to select which intersections you're looking for, right? There's 4 of them, so I'm going to put the cursor close to each one and figure out each one individually. So this is a little tedious, I guess. But anyway, now I'm getting close to that one. I don't have to go all the way, though. It knows it's going to find the closest one to there. Enter. And let's see. Let's calculating it. There, it says, and it found the intersection right there, and it says x equals 0.523. 0.523, all right. It gives it in this as a decimal, radian and decimal measure, but I have radians as pi over 6 here, so let's check. I had my first intersection at pi over 6, so let me calculate pi over 6, 0.523, let me check. Second pi divided by 6, 0.523. All right, so it did find that same point, right? And your job is to find all 4 points. And so let me see the graph again. Graph it. Now go to second calc again, intersection number 5, and now first curve, enter second curve. Does it know it's underlined? Second curve, and then guess. So now I have to get closer to this, to the next intersection I want. Let me go like that. That's close enough. Enter. Now it should be able to calculate that point. There it is. And it says 2.61. And again, if I double check that, I'm pretty sure that would be 5 pi over 6. And that's how you can find the 4 solutions. All right. Great. So you've learned all about trig, graphing, and now how to graph and find solutions by graphing. So these ones that you could solve algebraically can also be solved just by graphing, using the graphing calculator. All right. Good job. Try the ones in the bottom.